Half a day students, for this video it's actually going to be very short. For this video we look at a special case of factoring, which is called the difference of squares. First we're going to look at this particular product of binomials. Look at this, we have 2a and 2a, same terms, 5 and 5. The only thing that differs is one's plus, one's minus. So for the first one's 2a times 2a, that becomes 4a squared outside. 2a times negative 5 becomes negative 10a inside, plus 10a, and last we have minus 25. When simplifying, you'll notice that these two middle terms cancel out. So our middle term essentially disappears, right? So I'm left with 4a squared minus 25. And basically 4a squared minus 25 we can view as a difference of squares because 4a squared is actually a perfect square. It's just 2a squared, right? And 25 we know is just 5 squared. So if ever you have something that can be written as a difference of squares where the first term and the second term are both perfect squares, then they have a special factorization called difference of squares, where it's just going to be the square root of the first one plus the square root of the second one, and then the same thing but with a minus. We actually might be able to see this more easily with something like x plus, let's go 10 times x minus 10. If I was to FOIL this, we'll try it right here. First becomes x squared outside minus 10x inside plus 10x. Last becomes minus 100. Simplifying, these two cancel, my middle term disappears. I have x squared minus 100. From there, I'm actually just going to rewrite this as a difference of squares just so I can see exactly how this is. X squared is just x squared, right? Minus 100 is 10 squared. And you'll notice that these are the same terms that we started with. So look at this. We have x and 10. Look, x plus 10, x minus 10. Same thing here. 2a and 5. 2a plus 5, 2a minus 5. Our terms are all the same. So now that we've already shown that there's a certain pattern whenever you have something like this, we're going to use the difference of squares, which is going to be on the next page. Okay, here, so we have the formula for the difference of two squares. A squared minus b squared is equal to a minus b times a plus b. I actually tend to write it as a plus b times a minus b, but it really does not matter. I notice a lot of people use it this way. I don't know why I've always done it this way. Okay, so the first thing I want to do is I want to write this a squared minus 4 as a difference of squares. I know they're both perfect squares. A squared is just a squared. And then 4 I know is just 2 squared. Again, this only works for perfect squares, and it only works for differences. So I can only have a minus sign in the inside. If it's plus, it's going to be cannot be factored. Okay, so this now, utilizing my formula, I know this is going to equal to something plus something, something minus something, right? So I'm going to use a and 2. A plus 2 times a minus 2. If you were to FOIL this out, you would get a squared minus 4. Same thing again. Now I have a number in front of my x squared. As long as that number is a perfect square, then it'll work. The square root of 25 is 5, right? So I have 5x squared minus 3 squared. From there, I can just use my formula. So this is equal to plus, right? And then minus. So 5x plus 3 times 5x minus 3. This last problem, do the same thing again. 4 is a perfect square, 25 is a perfect square. I can do this. So this I can rewrite as 2c squared minus 5 squared. From there, I know it's going to be 2c plus 5, 2c minus 5. So you'll notice that this is so much easier Then solving using the normal way of factoring, or quadratic formula, or even solving algebraically normally by solving for c. So this is one of those formulas that you're going to be using a lot. It's one that's very, very, very helpful. So I suggest you memorize it and what it applies to. Again, this only works when your first and second terms are perfect squares, and only when it's minus.